Here is the current system design. Each stop on the map is equipped with its own button. For the purposes of the prototype, the system will only return values from the blue and orange lines. The system is limited to these two lines by the amount of digital inputs and outputs that the Arduino Mega has. Using these two intersecting train lines to test out the interface will provide us with a good idea of how well the system can perform. An Arduino board with more digital connectors is likely right around the corner as technology continues to get smaller and cheaper on a daily basis. Incorporating live feeds from the MBTA website has been a goal of this project. It is certainly feasible, but requires a few steps I am not currently equipped to manage. The easiest way to enhance the system would be to utilize the Google Transit widget. Inputs from this widget are addresses and locations, so the system would require a keyboard. This would allow for users to further customize their travel with even less knowledge of the T system. The development of a back-projected keyboard that requires less space for display would make a new, more specific kind of display possible. Ideally, everyone in the world would have a smartphone one day. If that happens, then the system becomes less viable, but not obsolete. Everyone loses objects of value, and phones are no exception. In this future scenario, the CPS is a backup navigation system for people who lose their phone. Here are a few stages of design thus far, which have shifted based on my understanding of technologies that are available and feasible. Once a model with the most recent design is built, prototype construction can begin. The budget for the prototype will incorporate the cost of the Arduino Mega, solarless breadboard, push buttons, 10K resistors, wiring, stepper motors, LEDs, a USB A to B cable, homemade spools, and the wooden housing container. This list is subject to small changes as the building process occurs. Once a working prototype has been developed, the urban demo can begin. The urban demo can occur within Ruggles Station. Tweaks to the system can be made based on how the users interact with it. To be an effective tool for the MBTA in the city of Boston, the display of CPS will need to include at a minimum all the train stations and potentially some major bus lines. When a prototype has been developed with all of these stops, a CPS can then be installed in any station within the T system. Initially, the number of CPS units installed would be based around the amount of traffic and swipes recorded that each station receives daily. Later on, data about the amount of use each CPS receives can be extracted from each unit. Based on the amount of use at each station, they can be quickly and easily reprogrammed and sent to stations that require more. This system doesn't need to be strictly limited to the city of Boston or even U.S. cities. In fact, it would likely be much more helpful in other parts of the world. In developing countries, there are much higher proportions of the population that don't own smartphones, if 3G networks have even been set up at all. Implementing a customized CPS for each city would transform the way its transit systems are used.